the James Webb Space Telescope has found a dormant beast. The most impressive space telescope within recent memory has, to be sure, gotten a black hole weighing 400 million solar masses that existed only 820 million years after the Big Bang. This discovery challenges our ongoing thoughts about the development processes in the early universe. But that's not all. Although the mass beast probably grew quickly, it is not currently gobbling up any matter whatsoever. Furthermore, it appears that the gravitational giant has taken an impossible-to-miss postprandial rest. Not all black holes are the same. While the formation of stellar black holes, which result from the collapse of stars, is fairly well known, their much more massive counterparts are still surrounded by enormous question marks. It's now thought, for sure, that virtually every galaxy is home to such a beast, weighing millions or even billions of solar masses. In contrast to their disastrous standing, supermassive black holes play a major role in cosmic evolution and can effectively be orbited by other celestial bodies in unstable orbits. But, as a result of ongoing research, it's now undisputed that a couple of 100 million years after the Big Bang, black holes with millions to billions of solar masses already existed in the universe. Yet, how could they get so enormous in such a brief time frame, and where did the matter required for that come from? Well, these are exactly the questions that are currently keeping space experts on their toes. One explanation depends on the direct collapse of massive gas clouds or rapid mergers. However, this is countered by the hypothesis that the young massive beasts somehow managed to surpass the supposed Eddington limit, which means they have accumulated more matter than astronomy allows. So, based on the objects observed, it's possible that these cosmic giants are already fully grown, or that they went through hyperactive periods of accumulation only to be followed by longer times of rest. What's more, surprisingly, experts have now figured out how to view a supermassive black hole that appears to follow this shift of excess and postprandial rest. The discovery was made by Roberto Molino and Ignace Jadbalis, who, along with their team, added the beast to the star diagrams with the assistance of the James Webb Telescope. To be more exact, the object is concealed in a far-off galaxy with the scientific designation GN 00111830. And considering that this star system existed 800 million years after the introduction of the universe, its central black hole, with 400 million solar masses, is exceptionally weighty. In fact, we are dealing with one of the most significant black holes that has been identified so far in this early cosmic epoch. Furthermore, it alone makes up nearly half of the total mass of its galaxy. By comparison, in present-day galaxies, the mass portion of these gravitational giants is generally only about 0.1%. The central black hole of the Milky Way tips the scales at just 4.2 million solar masses, quite a heavyweight as a poor eater. Considering these aspects and proportions, one could expect the recently discovered black hole to be an unquenchable pig. However, shockingly, the exact opposite is the case. In reality, it's not especially active or growing. Rather, it devours multiple times less matter than would be expected for a black hole of this size. In figures, this amounts to the black hole's growth rate being only 0.02% of its maximum, and it appears to be essentially dormant. But how is that even conceivable? How could a black hole with 400 million solar masses have no appetite at all? To find out, the researchers created an astrophysical model in which they considered several possible scenarios. This led to an astonishing interim result. The presence of the monster couldn't be explained by normal steady development, which scrapes against the limit. Surprisingly, this also applied to the case in which the black hole arose from an especially massive predecessor formed by a collapse. The alternative situation turned out to be much more plausible. Though it may seem like an inconsistency at first, according to this scenario, the black hole first went through a relatively short but much more intense period of growth before it switched to a resting mode. According to the scientists, it was the ferocious eating sprees that allowed the object to grow to its observed size. Overall, the model simulation shows that the giant devoured matter at a rate above the maximum limit for a while. Around 5 to 10 million years thus, it likewise became excessively quick and eaten up the whole grandiose smorgasbord in its area. In the wake of gulping practically all the matter in its area, the dark opening needed further supplies and fell into a sort of stomach-related rest, in which it accumulated next to no matter. As indicated by gauges, the rest might have gone on for around 100 million years, and the mass beast might have followed an example that was perhaps normal of the enormous dark openings of the youthful universe. Anyway, the degree to which said example will be affirmed by equivalent disclosures in What's in Store is another matter completely. Since the torpid dark openings radiate very little radiation, it is even more troublesome to recognize them in the immensity of space. The way that the analysts viewed one of them at everything was really a genuine fortunate turn of events, and the James Webb Telescope was simply able to recognize it because of its phenomenal size. This dark opening surpasses the Eddington limit by a factor of 40, so while the last gravitational beast still needed hunger, the next one presents itself as even more insatiable. The James Webb Telescope has recently found another dark opening that is standing out with an amazingly enormous mass and even showing an incredible accumulation rate. As referenced by the predominant theory, the development pace of a dark opening is really restricted by the Eddington limit. Well, actually, in light of the fact that the object that the specialists from the Public Optical Infrared Stargazing Research Facility have now found surpasses the maximum eating rate to a nearly absurdly huge degree. The specialists had previously inspected a progression of optically apparent yet X-ray bright system centers in the early universe, and the examinations with the spectroscopic instruments of the James Webb Telescope showed that these are dust-covered, very gigantic dark openings. And yet one structure specifically stood out from the already rare setup, named Cover 568. This dark opening existed for under 1.5 billion years after the Big Bang, and its unmatched brilliance in the X-ray range demonstrated an incredibly high gradual addition rate. By astounding, we truly mean astonishing. The energy delivered was, in fact, multiple times more significant than that of the other noticed early galaxy centers. Moreover, the follow-up study uncovered that the mass ratio is likewise amazing to say the least. While the dark opening weighs about 7 million solar masses, the mass of its home system is only 200 million solar masses, which is nearly nothing for a functioning cosmic core of this energy in size. In combination with the suddenly strong outpouring of hot gas that was detected nearby the very gigantic dark opening, the specialists presume that the dark opening is accumulating matter at a speed never before seen in such detail. The genuine growth rate surpasses as far as possible by a factor of 40. Regarding this unprecedented super Eddington gradual addition, the object, which at first weighed a mere 100 solar masses, might have gained a great 7 million solar masses within a couple of million years. And this, mind you, in the beginning stages of the universe, when, according to our understanding, the first worlds were also formed. But how is it that the growth of matter onto a dark opening is restricted by any stretch of the imagination? Well, when the glow surpasses the Eddington limit, the related radiation pressure becomes tremendous to such an extent that it is hence pushed to fall material outwards. Simultaneously, the energy supply is removed, which means that the interaction is basically automatic, and the iridescence drops beneath the limit once more. The material can, by and large, be absorbed well, in some sense on paper. However, since Cover 568 is clearly not very inspired by our hypothetical considerations, it simply abuses the Eddington limit imposed on it. According to the cosmologists, this is the first time in history that a system in the early universe has been found to overload its central mass of dark opening to such a sensational degree. Moreover, this unique discovery epitomizes nothing less than the unequivocal proof that super Eddington growth really occurred in the early universe. Yet, analysts suspect that the uninhibited development stages were restricted in time. If future disclosures confirm this hypothesis, Cover 568 could represent a previously absent key that shows us how the first gigantic dark openings were able to grow so large so quickly. In the future, scientists will need to look for additional instances of super Eddington accumulation and determine how common such incredible growth rates really were at that time and how long they lasted. And now, you can decide how long your click on approval and subscribe button will last. Become part of our community now, so you won't miss another video from us again. We'll see you soon.